So, hello everyone. We are starting a new chapter that is called current electricity. So, in class 9, you have learned about this chapter. That is the beginning. So, we will be learning that chapter now. And as we move 11, 12, class 11, class 12, we will be learning more about those current. Okay. So remember from our childhood, from class 7, 8, you are learning about current electricity, static electricity. So we are starting from little bit backward, that is from class 9. So chapter is current electricity. So we all know what is current. Current is the flow of electrons through a conductor. Remember, current is the flow of electrons through a conductor. So we can start current electricity by defining it. So remember, current, the flow of electrons, from one end to another end of a conductor is called current. So remember, when electron flows from one end to another end of a conductor, that is called current. So remember, current is defined as the rate of flow of charge through a conductor. So we can write current as also, it is another definition I am writing, that is rate of flow of electrons through a conductor. So I am assuming, remember, current is denoted by I, we all know, is equals to charge, total charge. I can write total charge, that is denoted by Q by time. Remember, so we are denoting time by T. And remember, start writing with me. And remember, when you are completing, this is called board work. When you can, if you write this thing, the 60% of your thing is done. Remember, so try to write the notes. It will help you. Or we all know, so we can write here. We know charge Q is equals to number of electrons N into E, where N is the number of electrons and E is the charge of an electron. So we all know charge of an electron is 1.6 into 10 to the power minus 19 coulomb. You should know it. And electron is negatively charged, that's why I am putting a negative sign over here. So this current I can write the total charge Q equals N into E, that is number of electrons into charge of an electrons by time. So remember, one more thing I'd like to tell you, that remember, the value of N, that is number of electrons, always will be 1, 2, 3 like this. It cannot be a decimal or it cannot be a fraction. So it is called the integral multiple of natural numbers. Remember this one. So this series is called integral multiple of natural numbers. Okay. So this is, remember, this thing, that is electron cannot flow by a fraction. This thing is called quantization of charge. So this is called quantization of charge. In class 9 you have learned this thing. So this is a question, remember. So this is a 2-mark question. What is quantization of charge? You should write this one, that N cannot be a negative term. So another question I'd like to tell you, that you all know that is current is equals to, now just now we have learned Q by T, total charge by time. And the SI unit of current, remember, SI unit of current, SI unit is ampere, remember, ampere, and it is denoted by the letter A. Okay, so from this relation I can write 1 ampere is equals to, the SI unit of charge is coulomb, so I am writing coulomb by 1 second. So now I'll form one definition of what is 1 ampere. So remember, 1 ampere is when 1 coulomb charge flows through a conductor in 1 second. I am repeating, when. So this is the definition of ampere, when 1 coulomb charge flows through a conductor, in 1 second. It is called 1 ampere. So this is the definition, when 1 coulomb charge, say this is a conductor, this is A, this is B, and here the total charge flows through the conductor is 1 coulomb in 1 second. Then we can tell the current flowing through AB is how much? 1 ampere. Okay. So one more question I'd like to tell you here, that is, this is on another question, that how much electron constitute a 1 coulomb charge. So I'm writing the question, how much or how many, I'll write it, how many electrons, I'm writing it like this, constitute 1 coulomb charge. So what should be my answer? So what is the meaning of this question? The meaning of this question is, we know charge of 1 electron, I have just written here, the charge of 1 electron is 1 minus 1.6 into 10 to the power minus 19 coulomb. So this is minus 19, is very less value. And so for 1 coulomb charge, how many electrons are required? Let's see how we can calculate that. So we know charge of an electron is, so I am doing the answer is charge of 1 electron, I am writing electron like this, is 1.6 into 10 to the power minus 19 coulomb. So for producing 1.6 into 10 to the power minus 19 coulomb charge, how many electrons are required? Only 1. So I am writing it like this, for 1.6 into 10 to the power minus 19 coulomb charge, number of electrons required is how much? 1. So we will apply the unitary method. Therefore, for 1 coulomb charge, number of electrons required, I can write it like this, 1 divided by 1.6 into 10 to the power minus 19. So remember, if you calculate it, its value will be coming roughly as 6.25 into 10 to the power 18. So remember, 6.25 into 10 to the power 18 number of electrons when flows through a conductor. So we can tell how much amount of charge is flowing, 1 coulomb. So remember, this is from here, this is very important, what is quantization of charge, and this is very important, how many electrons constitute 1 coulomb charge. Now there are a few smaller units of current. Remember, we have learnt about ampere. Now smaller units of current, you have to know little bit everything part wise. So see here. So now I'll start smaller units of current. So in class 10 we will be learning few smaller units like milliampere, microampere. So these are called millicoulomb. Same thing, milliampere, microampere, millicoulomb, microcoulomb. So little bit conversion, all the thing goes like this. First of all, current, we will start with charge, unit of charge. Remember, units of charge. So what are the units, smaller units of charge? Remember, SI unit of charge, SI unit of charge is, remember, coulomb. So I'll write it like this, coulomb. Okay, and it is denoted by C. So smaller units are 1 millicoulomb. 1 millicoulomb is equals 10 to the power minus 3 coulomb. Okay, so 1 microcoulomb. Millicoulomb is denoted by MC. So microcoulomb is mu c. It should be 10 to the power minus 6 coulomb. And 1 nanocoulomb, it is denoted by Nc. So it will be 10 to the power minus 9 coulomb. Okay, these are the smaller units of charge. Now if we consider the smaller units of current, so it will be like this. So I'll write it, smaller units of current is 1 milliampere. Remember, ampere is equal to, same thing goes like this. So 10 to the power minus 3 ampere, and milliampere is denoted by Ma, and 1 microampere, it is denoted by mu A, and it is like this, 10 to the power minus 6 ampere. So remember these two. Okay, and related to current, remember, we have learned quantization of charge. We have learned how much electron constitute 1 coulomb of charge. Now we will learn little bit about a conceptual thing. So remember, current is, look at it very carefully, you have to understand everything. So let us assume this is a conductor and electrons are flowing through it. So within this one, we all know any substance in the world can be classified into two categories. One is called conductors, another are called insulators. So what are conductors? These are class 8, 9 things. So conductors are the substance which allows the flow of electrons through them. Okay, so which have got free electrons, such as metals, non-metals, all are maximum metals are good conductors of electricity. So the substances which have free electrons and which allows the passage of current through them are called conductors, and metals are good conductors. Few examples I can give: copper, aluminium, silver. And what about non-conductors? Non-conductors are does not permit or does not allow the flow of electrons through them. That's why they are called non-conductors or insulators. And what are the wood, plastic, or maximum non-metals are non-conductors of electricity. Okay, so now when electron flows through a conductor, here is one electron, so here is another electron, here is another electron. So this electron collide with this one, this electron collide with this one. So remember, after collision, this can move in this direction, this can move in any direction. After collision, nobody knows in which direction the electron will flow. So remember one thing, why I am telling you, current is a scalar quantity. Scalar quantity. Remember, current is a scalar quantity because when electron flows through a conductor, remember, they collide with each other. They can go any direction. So direction is not there. So we are telling that electrons are moving from here to here, but during this path, during this journey, they collide. Many collisions will be there, and in class 12 we will be learning one thing that is called relaxation time and average velocity of free electrons. So we will be doing it in class 12. So one more thing I'd like to tell, that remember, say this is a very good question coming in your way, hopefully. So it is a very conceptual question. Say there are n1 number of positive charge, n1 number of, and positive charge known as cations and negative charge is called are anions. So I am assuming n1 number of positive charge. Positive charge. Positive charge how much? Q1. Each charge having charge Q1 is moving in this direction, and n2 number of negative charge are moving in this direction. Okay, so this is Q2. Each negative charge is having charge Q2. So, and in time t, and the time taken for the flow of charge is t. So I can easily write, remember this thing, this is another important thing, I, that is in this type of case, current is given as N1 Q1 plus N2 Q2 divided by T. So remember this thing. So where N1 is the number of positive charge, Q1 is the positive charge of each positive charge, and N2 is the number of negative charge, and Q2 is the amount of charge each negative charge is carrying. Okay, so that's about introduction of current. So gradually we are getting into this chapter. So we'll start with potential, very important thing. So I am starting with potential. So remember one thing, from the beginning I am telling you one thing, that this is a current carrying wire, this is A and this is B. Electrons are flowing through it. By my question is, why electrons are flowing? Okay, so why electrons are flowing? There must be some cause for electrons to flow from here to here. Otherwise electron cannot move. Exactly what you have learned in heat. When a cold body is in touch with a hot body, the heat energy transferred from hot body to cold body. If we put water into different levels, water always flows from higher level to the lower level. Exactly like current, electrons cannot move from one end of the conductor to another end of the conductor without any cause. They will not move. There must be some cause. That cause is called potential. So initially this is a very raw definition to this. So potential is the cause. Remember, first point I can write potential. It is the cause for which electrons flows from one end to another end of a conductor. Remember this one. From one end to another end of a conductor. Okay. Now let's begin our discussion from our childhood concept, that any element, isolated gaseous element, when it loses electrons, it becomes what? Positively charged. And any element, isolated gaseous element, when gains electrons, it becomes negatively charged. So that is the funda of positive and negative charge. So if I tell that in this conductor, this is a wire, copper wire. So this end name is A and it is positive, and this end is B, this is negative. So actually what I am telling positive charge means, see here, after losing, so positive charge means there is a deficiency of electron. So the number of electrons which are required for stabilization is not there. So in this point A, it is electron deficient. Remember, electron deficient. Okay, and the point where I have put a negative sign, you can see negative signs, negative charge can be formed by gaining of electrons. So there is an excess of electrons. So at B, there is an excess of electrons. Okay, so now tell me, this point at A, there is a deficiency of electron. At point B, there is an excess of electrons. So invariably, the electrons will flow from excess region to the deficient region. So remember, electrons will be flowing from negative to the positive. What flowing? Electrons are flowing. But we tell that current is flowing from positive to negative. Why it is like this? So remember, there is a convention, means a rule, that is all over the world it is maintained, that electron flows. This is the logic. Why? Because anything will be flowing. If it has a chance to flow from an excess region to a deficient region. In chemistry also you will be learning this type of things. So electrons moves from a excess region to a deficient region. That is the direction in which electron is flowing. And we tell conventionally that current flows from positive to negative end. So the direction in which electron flows, is called, remember, electronic current. Okay, and the direction what we have given here, arrow, that is positive to negative, this is called conventional current. This is the direction of conventional current. Remember this. So we are telling about potential. So it is the cause for which electron moves from one end to another end of a conductor. So why electron moves from one end to another end of a conductor? Because if we insert a positive and negative, now I'll use that word, potential, then electrons will flow from the excess region, that is the negative, to the deficient region, that is the positive. So electron always flows from negative to positive. So the direction in which the electron flows through a conductor is called electronic current. And we used to put this arrow from positive to negative when we are representing current in the circuit. That direction is known as conventional current. Remember this. So talking about potential, remember another way of thinking, another way of presenting it is the amount of work. It is, so if you want to place, say this is a conductor, I am telling you. So this is a very funny thing and conceptual thing, otherwise you will be never been able to understood this one. So this is point A and this is point B. I am taking a charge Q from A to B. Okay. So we have to put some energy, some work has to be done. Otherwise, the charge cannot move from one place to another place. So we have to put some energy, we have to do some work. So amount of work that has to be done in order to move an electron from one end to another end of a conductor is called the potential. Remember. So amount of work that has to be done in order to move an electron from one end to another unit distance, anything. So remember another definition of potential. Potential Potential is work done divided by charge. Remember this one. Potential is equals work done by charge.